This is a 74LS93 IC. It has 4 JK flip-flops and falling edge clocks. There are 4 clear buttons here. The clear button means whenever the clear button is active, that is whenever this one is 0, the output becomes 0 for each of the flip-flops. So basically when this one is 0 here, everything is 0 here, all the clears are 0 and output will be forced to 0. So with this one we will develop a mod 9 counter. Mod 9 counter is one that counts from 0 to 8, 1, 2, 3 up to 8, and then it goes back to 0 to 8, so it counts up to 8 only. So that means whenever 9 comes, we will first connect it as a normal up counter, as an ordinary up counter, and when 9 happens we have to clear everything. So 9 means 1001, and if we observe that this one is the J3 here, so this is Q3 here and this is Q0 here, so this is the most significant, this is the least significant, and when most significant and least significant both are 1, that only happens, that's the first time it happens in 9. When it is 9, that's the first time both are 1. So basically if we connect these two just to this NAND gate input, and this NAND gate's output is connected to the clear, so what will happen is immediately whenever 1001 will happen, that means when Q3 is 1 and Q0 is also 1, immediately the output will be 0 and everything will be cleared. So before that, for any other occasion, both of them are never 1. Before up to 0 to 8, both of them are never 1. 8 is 1 0 0 0, so this is 1, this is 0, still the output will be 1. So this is 1 here, this is 0 here, the output will be 1 for 8, and for any binary number before that up to 7, always Q3 is 0, so the output will be 1 anyway. So only when 9 is happening, both of these are 1, so both of them are 1 here and the output will be 0 and everything will be cleared. So that's understood. Now what I will do is I will connect this one as a up counter, so it will be an asynchronous one. So this is the main clock here, and this output will be connected here, this output will be, and we will see that it will act as an ordinary up counter. So if this is clock here, the clock goes like that, and it's a falling edge, so it will work on the falling edges like that. So Q0 will be like that, it starts from 0, this is Q0. Q1 will be again, since Q0 is becoming clock for Q1, Q1 is like that, and Q2 will be Q1 will be clock for Q2, so Q2 will be like that, and of course Q3 will be there. So yeah, so we can see that this is counting fine, 0 0, then 0 0 0 1, then 0 0 1 0, then 0 0 1 1, like that, then 0 1 0 0, then 0 1 0 1, 0 1 1 0, so it should come here actually, then 0 1 1 1, then here 1 0 0 0, and after that it will happen 1 0 1 1. Immediately when this is happening 9, immediately everything will be cleared, so this one will go down, because of whenever this is 9, everything will be cleared, and that will happen because this clear is an asynchronous clear. That means whenever the input of this clear is 0, this pin gets 0, immediately output is cleared. If it were a synchronous clear, it would have waited for the next clock to come, but since it is an asynchronous one, it will be immediately cleared. So there will be a small spike and it will go down. Again it will count from 0. So from here everything will start again from this 0, 0, 0. So this is a bit clumsy because I haven't quite drawn it properly. Like it should be like that and then like that, but anyway, I hope the conception is clear. So this is a mod 9 counter that counts from 0 to 8 and using a 74LS93 IC which has asynchronous clear.